your boy, Mr. AC. Yo, what's up? Here to present with you another video into continuity, my friends. So before we do that, I thought it would be important to review what we're going to call piecewise functions. And now this video really is just going to help us build the groundwork for what's to come. So just as review, all right, let's look at this first problem over here. Okay, now notice it says x, okay, it's less than 4, right? And the way I like to think of it is I like to put 3 dots in the corner here. Notice that the x is closer to the side. So you ask yourself this question, is the x next to the side with more dots or less dots? Well, there's 1 dot versus 2. So this is x is less than 4. And it's not equal to 4 because it doesn't have the underneath line. So that means we're going to be at 4. We put an open circle, just review. And that means we need to be less than 4. And so that means we draw arrow going this direction, right? So x has to be less than 4. Good. Okay, over here, x is, well, just kind of that same idea. I like to put my 3 dots right here. Well, the x is closer to the side with more dots. So x is bigger than or greater because it has the equal to symbol than -5. So I like to fill in my circle here. And then that means I need to be greater than, which means I need to be greater than, which means I'm heading towards the positive directions. All right, here we're saying x, if you start in the middle and we'll read it this way. X is less than 5, okay, but it doesn't have the equal to symbol. Boom. And over here is x is equal to or greater than -1. So there it is. Cool. Fill that in. Okay, let's reread that. X is less than 5. So that means you're going this way. And this is x is bigger than. So that just means everything in between here, my friends. Down below number 4 is a little tricky because it says x cannot equal 2. So let's just start over here. We cannot equal 2. So I'll put an open circle. And if we can't equal 2, well, what is that telling us? Well, x cannot equal 2, but can x be 3? Well, my friends, of course it can. Of course we can be 3 because it's your boy. You cannot be 2, but you can be anything else. 3, 4, 5, right? As long as you're not equal to 2. So that means we can be everything else except 2. All right, wonderful, my friends. And if we look up here, we can rewrite this to be, well, x is less than or equal to -5, and this over here to be x is greater than -1, okay? So just reviewing inequalities so that we can begin to learn the problems that we have at hand. Let's check it out. So look at this graph here. Well, what do you notice? So here's the mathematical expression. We have this, oh, there should be a negative symbol there, by the way. We have this quadratic equation, comma, and it says x cannot equal 1. Well, remember, we're saying if x cannot equal 1, we can be everything else except 1. So that means we're going to be everything else except the y value at 1. That's why you see a hole when x is equal to 1 there. Okay, so we can be everything else except 1. So let's look at this right here. Well, we have this graph a little bit trickier, right? We're saying, I don't know what this equation is. So this is some equation here. I don't know what it is, but what we're saying basically is we have some equation, all right, like x to the 3rd plus 2x squared plus 1, something random, and I'm just showing you how to work with these. Well, can it be everything else except for what? Well, it can be 2. It has a y value 2. It can be anywhere else. The only spot that it's not able to exist is at x equals 1, right here at the hole. So we just need to write that x cannot equal 1, but it can equal everything else, okay? Now, last but not least, well, we notice we have a filled in circle. So that means, well, when x is actually equal to 1, what is the y value? Well, the y value is 7, okay? So this mathematical expression can be defined as such, okay? When your x value is 1, your y value is 7. And when x cannot equal 1, well, that means you're going to have this function the rest of the way there, okay? It's a little tricky, but we're going to get the hang of it as much as we can. All right, let's take a look at this function here. Now, I always like to read the inequality first before I begin to go over here because these here represents the y value. So this says x is less than or equal to 1. So when x is less than or equal to 1, that's saying that our y value will be 11. So you notice over here it's filled in, and anything less than 1, the y value should stay 11, which is exactly what we have over here. Okay, and over here, this says when x is greater than 1, when x is greater than 1, that means we're going to have this function, right? So that, well, we know it's an open hole because it doesn't have an equal to symbol. And then that means when x is greater than 1, meaning we're going in this direction, that means we need to graph our function going in this way, which is negative x plus 9, which means we're just going down 1 over 1, okay? And let's go over here. This one looks a little tricky here, but really it's just kind of that, it's just telling us here that when x is less than or equal to 1 and x is greater than or equal to negative 1, the y value is 4. So in between these two numbers, the y value is 4. So in between negative 1 and 1, your y value is 4. And over here this says in between 1 and 3, you're going to get this linear function. But the biggest thing is that this doesn't have the equal to symbol. So at 1, it should be an open hole, which is what we see right there. And at 3, it should be filled in circle, and we're going to be everything in between. Okay, and that's kind of the big thing I wanted to hit on, all right, is, okay, when you see a graph that looks like this, when you see a graph that looks like this here, when you have something from the left and something from the right, you're going to need to have some kind of inequality symbol that looks like this, right? This is saying x is less than or equal to 1, x is greater than 1. You're going to have two different functions from the left and from the right. But when we look at a problem like this right here, well, we notice that when we just have a function everywhere else except for 1, then we label it to be x is not equal to 1, all right? So for example, if I was to create a graph that looks something like this right here, boom. Well, you know, if I was to write an equation for this, sorry about that, we would have some equation, and let's call this 3, okay? That means we have some equation here, okay? Let me put it here, okay? And well, we're saying if this yellow line, let me change the color so that this is purple, okay? If we're saying the yellow line is some equation, well, what can we conclude? Can it be everything else except for 3? Well, yeah, it can be everything else. It's all defined. It's all defined everywhere else except for 3. So x can be everything else except for 3. Now, what can we conclude? Well, what happens when x is equal to 3? Well, we're going to be some y value up here, right? So let's go ahead and call this, I don't know, 7. So now what we're saying is, well, when x is equal to 3, well, my y value is 7, right? And that's the difference between this graph versus what if I drew something like this right here. Okay. Cool. Pick a random number. I'll pick 8. All right, and I'll put an open circle. Let's color code these. So let's go ahead and put this as this, and let's go ahead and do this. Okay, and let's go ahead and do something like this, and let's go something like that. Okay. Well, if I was to write an equation for this, my friends, if I was to write an equation for this, I'd have f of x is equal to, okay. All right. Well, look over here, this function right here, right? We're interested in the value 8. So you can immediately know, okay, we're going to have xx. Okay, let's write that here. Well, first things first, okay, what can we conclude about this graph right here? Well, we know that this equation, let's call this f of x. Actually, let's call this P, and let's call this G, okay? Just some random letters. We know that the equation for P, okay, well, what needs to be true about your x values? Well, they exist when x is less than 8, right? So this equation P is only possible when x is less than 8, right? Because it only exists when it's less than 8. The x values are less than, and that's why it's going in that direction. And we can also conclude that it doesn't have the equal to symbol because it's not equal to, it's an open circle. And over here, well, we can say, well, x has to be greater than 8 or equal to, and that's going to be the equation G, okay? And notice a big difference between the two. This is creating a jump, because you're going to have something from the left and something from the right, okay, that's being defined, versus the one up above, which is telling us that we have some function. It just doesn't exist at a certain point, but it does somewhere else, okay? Now this is really tricky, and really it's going to come down to just being able to identify it when we begin to do some problems together. So thank you for listening on in, and let's go ahead.